Hello, my name is Charles Shear. I'm the Vision Science Consultant for Burtech Corporation, and we're bringing you another in the series of videos on the clinical uses of the BBT instrument. Today we want to discuss vision motion sensitivity and how the BVT's backgrounds can be used to reduce that. Vision motion sensitivity is a disturbance that negatively affects a subject's vision and balance. This can occur after concussion, strokes, and traumatic brain injuries. This is frequently due to a mismatch between the subject's peripheral vision, central vision, and the vestibular system. In other words, the pieces of the puzzles just don't quite fit together or become disconnected. The magno or peripheral vision system is our motion detection system. It becomes hypersensitive and out of sync for many patients. This sends confusing information to the vestibular and central vision systems, sometimes overwhelming and overloading them. This is particularly true when it is a high contrast or fast moving stimuli, such as in driving. Loud noises, confusing sounds, the type of ambient lighting, and even patterns on the floor may also have a negative effect in the processing of all this visual information. Severe mismatches and overwhelming stimulation of these three systems may cause the subject to lose balance and even fall. Our challenge as clinicians is to get those pieces to fit back together again in the right way. Of all the programs on the BVT instrument, the one that's best for working with VMS is the peripheral mode. And as always, the best place to start is by establishing a baseline for our patient. We start with a black background and a green target. And for this demonstration, we're only going to use the touch mode. As they adapt and get better at this, then we can add balance and even combination into this. But you do need to be careful not to add too much too soon, is because these are strong vestibular stimuli and could induce a fall risk. For this demonstration, we'll also set the time to 15 seconds instead of the normal 30. And here's when we first start to begin to use the unique focus zone box. We're going to set this focus zone size to small, and that'll keep the targets all within the central 30 degrees. And next we'll set the distribution to 100%, which will put all the targets within that focus zone. There's no peripheral stimuli either to distract them or disturb them. Next, we'll set the target distribution to 50%, placing half the targets in the central vision and the other half in the peripheral vision. This gives us the second baseline, which shows us what happens when the central and peripheral vision systems are interacting. Since VMS is most dramatically affected by high contrast, fast moving objects with distinct borders, OKN stripes with horizontal, vertical, and concentric orientations lend themselves nicely for our purposes. Instead of a black background, we're simply going to select the OKN stripes. We'll touch the little controller button, and that brings up our box, which lets us control both the speed and direction of the stripes. It's often a good idea to get a baseline of the OKN strikes without any movement at all, as they alone can be sometimes disturbing for some patients. But it's really when we start adding the movement that things get interesting. For this example, we'll set the speed to 0.5. You could go in smaller increments if you want. When they've gotten good at their scores at this speed, we want them to be up about 90% of baseline. Then we're going to increase the speed. Here we're at 1.5. And you can see how much more of a challenge this is. And next we can change the direction or the speed, either one we want. Here we'll do both, and we'll increase the speed to 2.5. Here we'll switch to a vertical motion. Don't be surprised if you get a significantly different response when you change orientation. These type of stripes will especially bother people when they're going up bleachers or walking down a pier or have patterns on the floor. And once again, we can reverse the direction. Here we're at a speed of 3.5, which is just about the maximum that you would use in rehab. The exception to that, of course, is if you're working with sports vision, and particularly with athletes with fast-moving sports or even motorsports. Once a patient does well with the traditional OKN stripes in all directions, I suggest using the concentric circles or optic flow targets. Notice how the background changes when we change contrast sensitivity. It tends to slow things down. And there's another video on just changing contrast and how that works. But for this purpose, we're going to use high contrast targets, and we're going to slow it back down to that 0.5 to start. When we refer to these as optic flow, this is really how it happens when you're moving forward. Things go from central to peripheral, and they get larger as they do that. And again, we'll increase the speed, and you see how much more of a challenge this is. Another variable is to use sine waves for the lines instead of square waves. This tends to soften the borders and reduce the vision motion sensitivity effect. Here we're moving at 3.5, which is pretty tough. This technique is also not limited to the peripheral mode of the BVT. Here is a brief example of using it with the go, no-go option to add a cognitive demand. If you choose the different size of the target patterns, you control how much is being presented in the central versus peripheral vision. The key points I'd like you to remember about this video are that the BVT can present OKN and optic flow stripes and control their direction, speed, and contrast. And that this technique is best used on the peripheral mode option, but it's available on many of the other programs. As always, we want to thank you for viewing this video and hope you will join us for more clinical application examples in the future. Thank you.